if the physics-based battery model were integrated with the vehicle model, it would take many hours to run just a single drive cycle simulation. But by replacing the detailed battery model with a meta model, the vehicle simulation could be done in just a minute.
Hi, good morning everyone. Welcome to our podcast on optimization and machine learning. I'm your host Abhishek, joined by
Divya.
And welcome to our guests Yanni and Ryan.
Thank you for having us.
We are very excited about this episode because machine learning and optimization are some of the hottest topics right now in all of engineering, even beyond engineering, I would say. So we are looking forward to this episode. We can start by having introductions from both of you.
Hi, I'm Yanni Papadimitriou. I'm working with Gamma Technologies over the last 14 years. I'm currently leading the development group working on optimization and machine learning tools. I have a background on electrical engineering and machine learning and computer science. And I'm also certified as a project manager professional by the PMI Institute.
Ryan Dudgeon, I've been with Gamma Technologies for 13 years, and I have a mechanical engineering background. I've spent 10 to 12 years working on different applications, including engine performance applications, engine aftertreatment, or exhaust aftertreatment applications. But currently I'm in our GUI group, Graphical User Interface group, and I focus on optimization and machine learning applications.
Thanks for joining us. I think also for our viewers, we have done a lot of episodes on the physics of different engineering that we do here, but I think today's take is also on how do we leverage all of those different physics solvers that we have to contribute to engineering design. I think it's a very different topic than what we have done so far too. So could you elaborate what we are going to talk about today and how that's beneficial to our customers?
Yeah, I guess so. I think there are two main topics that we'll cover. So model-based optimization, which is I would define as like the search for the best set of inputs that would achieve, say, one or multiple objectives that are attached to, say, system outputs. So we have at Gamma, we're modeling all kinds of different systems, and there are going to be key inputs and key outputs, and the modeling engineer is going to be interested at various stages of the modeling process to optimize those inputs in order to, say, maximize an output, minimize a different output, or juggle the minimization or maximization of multiple different outputs, which can be a pretty complex task. So an optimizer tool is really a productivity tool to help the modeler in a more automated fashion find these optimal designs, so to speak.
So can you put it more in an engineering context? Like, let's say I'm thinking about optimizing something like a thermal model for an electric vehicle or for an engine. So how would optimization work in that kind of case? Am I looking to optimize temperatures? Am I looking to optimize comfort levels? If you could just walk us through engineering example.
Yeah, there's really an infinite number of situations that could be tackled with an optimizer tool. So in context of like thermal management, one might be interested in maximizing heat rates or maximizing efficiency. I mean, all kinds of different things. And the GT Optimizer is integrated within GT Suite. So for any GT model, you can activate the optimizer, and the setup is pretty simple. You just specify what are the input parameter values that you're interested in having the optimizer vary, and then you specify one or multiple outputs that you want to minimize or maximize. And yeah, there are a few other setup decisions to make, and then with the optimizer enabled, you just click the run button, and instead of just a standard simulation that gets launched, an optimizer process gets launched, and this optimizer, kind of as a parent process, will iteratively run the model multiple times. Could be dozens of iterations, hundreds of iterations, or thousands of iterations, depending on the complexity of the optimization problem. So through this iterative process, it's trying to find the best combination of model inputs to meet those objectives.
And I would like to add that at the end, you can review how the optimization process progressed during the time, review your results either in the optimizer or later on inside our results viewer, GT Post. We also provide, in terms of, in case of multi-objective optimizations, we also provide the ability for the engineer to review all the optimal results, and based on some criteria, decide which of them are the most interesting to them, or the ones that they would pick if they would like to emphasize or to focus on a specific range of the input factors.
Yeah, I would maybe tack on another thing. Yanni mentioned the interface to monitor an optimization, and I mean, it's worth noting that there are a whole host of different optimization tools that one could go to in the context of modeling and simulation. Like, there's Python scripts, all kinds of other scripts where you can find different optimization search algorithms. You can find a search algorithm anywhere, but it's all about bringing it together and making a user experience out of it. All the plots that go into optimization monitoring, how to handle all the different inputs and outputs to the GT model, handling solver failures or DAT creation failures. So it's all these intangibles that make
running distributed.
Running distributed, yes. Restarting an optimization when you've only, you've gone halfway and you need to stop for a while. So all of these, productivity tools that go into the GT Optimizer to make it as powerful as it is really very not insignificant.
I think the real value is in the package, you would say, right? Because we closely package everything so you can fully take advantage of all the features we use in GT pre-processing, post-processing as opposed to using a third-party tool. I think you say that's the...
That was said much better than I was trying to say, but yes, the package is what makes the GT Optimizer fast and user-friendly for the user to configure and use in their day-to-day activities.
Yeah, sounds like a very powerful tool. As an engineer, clicking a button and getting the best design is, I think, the best outcome I can hope for from a tool. And I think with the fast pace of product design, especially for engineering nowadays, going to market, being the first is very, very important. And gaining the last squeeze of efficiency is also very, very important to distinguish yourself. So any kind of integrated optimizer is going to help in all of these a great deal.
And we see that year after year, the use of optimizer increases We are moving towards, application-specific optimizations. We are adding more functionality related to the optimizer, and we see this with our customers. They're using it more and more.
Yeah.
I would also add that the GT optimizer, like the level of maturation that it's reached, has also been greatly driven by our in-house usage at Gamma Technologies. There's a large number of our solver developers who rely on it for kind of tweaking their solver solutions. And so, like, for example, the combustion group was one of the early groups to drive the development of the optimizer.
Yeah, I think we are also heavy users of the optimizer. I think it's a great way to also test out a wide range of different cases for the solution that we are developing. So yeah, I think I've definitely used it. I'm sure Abhishek has too.
Yeah, I mean, I think one of the best things I found is the sensitivity analysis, because as an engineer I'm dealing with an infinite number of inputs a lot of times, but to know which one is the most important, I think, is the best thing that I have found.
We also talk about how some of the application side, on the customer side, use our optimization models.
Yeah, I would roughly divide the application use cases into two groups. I think the first group would be for what we would call like model calibration. So the idea of having a GT model that you also have for a system that you also have measurement data for. And the idea is to use that measurement data to, I guess, train the GT model to make it more realistic so that it better aligns with that measurement data. And to do that, you're going to have one or multiple different, say, tuning parameters at your disposal in order to get the key model outputs to better align with the measurement data. So that's a very common usage of the optimizer for basically all the GT applications that GT Suite is used for. So simple example would be some kind of flow system where you have measurement data for some kind of pressure drop through a component. And maybe there's an orifice diameter or some other tuning parameter at your disposal, and the optimizer's just varying this orifice diameter to get the predicted pressure drop to better align with the measurement values. So that's an example of some like steady state type measurement data that you might have, but we also have situations where we have transient measurement data, for example, for a battery application. So the battery team uses the optimizer a lot for these transient model calibrations where you have profiles of voltage and temperature that coming from measurement data that they want their battery models to align with. So that's another example of model calibration. So talked a lot about model calibration there. The second main use case of optimization would be what I would call engineering design, where you have a calibrated model already, you have confidence in the predictions of this model, and you want to use the model to its full potential to minimize testing. So you can put this model through all kinds of different simulations to bypass physical testing and arrive at optimal designs without physical testing. So you use an optimizer to vary the design parameters that you have to work with in order to, say, maximize efficiencies, minimize fuel consumption. As one example, say, a heat exchanger design where you're trying to come up with an optimal heat exchanger geometry. So numbers of tubes and fins and the geometry of the tubes and fins in this heat exchanger, and say you might have multiple goals of the optimization, say maximize the heat transfer of this component, minimize the mass or the weight of the component, and that brings into question like the competing objectives, which are pretty prevalent in optimization. So you can imagine like if you're trying to maximize the heat transfer of a heat exchanger, you're going to need a lot of surface area. So kind of the equivalent of maximizing the surface area, but you don't want to make the component too large. So there's going to be a trade-off between those two objectives. And an optimizer can help you kind of visualize the trade-off between those competing objectives and help the design engineer kind of narrow down and find a best design that weighs those two competing objectives.
Those are some very interesting examples. Thanks, Ryan. I think something more interesting when we are talking about the integrated abilities that we offer in our tool, and that's something that I think we are focusing a lot more these days, is also machine learning capabilities. Would you be able to talk a little bit more than
We have invested a lot of effort and time designing a tool that is very well integrated with the rest of the GT Suite applications. The way that we import the data directly from the simulation data, or in case you have measurements data, and then you import them into a machine learning project. You select your factors, you select your responses, you work with your data sets, and then create the meta models, and then back into your models, you export them and you reuse them. It's a very well integrated process. And I think this is what differentiates us compared to the million of Python-based frameworks that are out there and can do a lot of the algorithmic work that we do as well. Again, what is unique here is that this tool is very well integrated with GT Suite.
Yeah, I think this integration or marriage of physics with optimization techniques and machine learning is probably what I would always look for, because you should have a physics basis of something, and then you now want to run it fast, you want to run it calibrated, you want to have so many things that you can put in a model, and just running physics, then getting a reduced order model out of that using the myriad machine learning techniques that are available in GT is a... I have used it myself for making my thermal management models faster. The refrigerant circuit is one of the most dynamic parts of the circuit, where we have transient changes in density, we have changes in compressor speed, we have changes in heat exchanger temperatures, and it basically is the bottleneck when you're trying to run a model. And we were very successfully able to replace our whole refrigerant circuit with a meta model of machine learning, and were able to basically make our simulations 40% faster, which now enables real time, which was not possible before with a physics-based model. So
that's exactly one of the main drivers for machine learning right now for us, the ability to export the meta model and use it in time or hardware constrained systems. That would be, for example, hardware in the loop systems, ECUs. Even we are able to run heavy physics-based systems into small devices like, I don't know, Arduino or Edge devices. We have this capability, and I think this is one of the main drivers for switching to a machine learning environment.
Ryan, I guess on the application side, you must be most familiar with how we are integrating, using it in hill systems, using it for I don't know, speeding up just the physics part, or let's say you replace parts of your model with a machine learning example so that you can focus on other important things like controls. If you could walk us through some of the unique or interesting use cases you think you've seen.
Yeah, I mean, most of the use cases for the machine learning tools that we provide really do center on, say, the need for speed. So speeding up models. So some of our application use cases, or some of our users will kind of train an entire GT model to a machine learning model, or what we call a meta model, just for the purpose of optimizing that model. As we talked about, the GT optimizer is a very, say, all-purpose optimization tool, but for some very slow models, it can make sense to do a machine learning approach to optimization where you run a DOE on that model, a design of experiments, and then train that DOE data to a meta model, and then optimize that meta model, which is very fast. So yeah, entire GT models could be trained to a meta model. But then you were involved with that project with where just a single sub model of a larger integrated model could be trained to a meta model to just sub out the physics of that sub model with a meta model to make that integrated model much faster.
I think it's also a great way that different teams in industries can cross collaborate. Only different integrated models from different teams could go as even meta models to someone like, say, in controls or in hardware in the loop.
Exactly.
Field.
Yeah, we just completed an in-house project pertaining to a battery application where a very detailed, like cell level battery model was trained to this new flavor of machine learning models that we call dynamic meta models, in order to allow the complex physics of this battery model to be integrated with a larger vehicle model. Because if the physics-based battery model were integrated with the vehicle model, it would take many hours to run just a single drive cycle simulation. But by replacing the detailed battery model with a meta model, the vehicle simulation could be done in just a minute. It was just such a drastic speed up.
Yeah, that's
Yeah.
amazing.
Yeah.
Like hours to a minute.
Yeah.
I mean, it's unthinkable before we had access to these kinds of techniques,
Yeah.
I guess. Is that something GT as an organization is looking at? Like, what would you say is the overall picture going forward? Like, we are a tool by engineers for engineers, isn't it? So, is that how we look at even incorporating these tools into our tool chain, frameworks, etc.?
So far, we have been focusing on regression algorithms, so need for speed,
Sure.
basically. We think it's important. We have found all these use cases that we really need this kind of speed. We are trying to expand to other ideas as well. So, for example, during this year, we had a couple of projects related to anomaly detection and predictive maintenance. It's something of really interest for us and our customers. We are exploring other technologies as well. For example, physics-informed neural networks. Since last year, we have a reinforcement learning implementation based on neurocontrollers. It's something that we have started working with. And of course, to some extent the buzzword of the day,
Yeah.
which is generative AI. We are trying to take a very careful approach on that. Identify those use cases that will bring true value, true benefits to our ecosystem. We know we are exploring the limitations, the challenges, and we are in the process of identifying what will be the tools we are going to create in this field as well.
We do have a new initiative as well, right, which was announced recently, the Neuro Initiative.
The Neuro Initiative, again, it's an umbrella idea. Under this umbrella exists all the existing tools like the optimizer, the machine learning assistant tool, but also all these new technologies that are about to come.
Or have come already.
Or come on our way.
Yeah.
It's definitely an area that it's full of interest, full of technical challenges in the positive way, and it's something that we're pursuing at full throttle right now.
Yeah. I think that's, as engineers, latest and greatest technologies are always the most interesting to work at, isn't
Exactly.
it? And
Exactly.
I think GD has the right mix of knowing when to apply what technology and then packaging it in a way that is very useful for an engineer who will use our tools for whatever purpose they want. I think, have you seen any example, Ryan, of where some of our customers have used all of these tools together for, I don't know, some engineering application?
Yeah, quite a number of customers use both our optimization and machine learning tools. So one example is Safran. They presented at our European conference a couple months ago, and they have a presentation that's available on our website that really highlights this entire package of tools in a nice way.
That's certainly a very exciting example. I'm sure we'll link it in our descriptions for anyone watching this on the video. For both of you, on concluding thoughts, you both have worked in this field for quite a while now. And it's definitely something which is growing and into more exciting opportunities too. Could you talk about how you got in and what keeps you going?
Yep.
Yeah,
Right.
I could go first. I guess, I like working in this area for quite a number of reasons. But maybe to keep it short, first of all, I've been working with Yanni for maybe 8 years now, and another guy in our group, Takis, and we have a new developer, Ava. The four of us have, we have a very innovative dynamic, and it's been great working with them over these years. Another reason I like this area is because it's very data focused, and a lot of aspects of numerical analysis, data science, statistics, which I really enjoy. And then finally, like me being in the our GUI group, our graphical application, graphical user interfaces group, I get to interface with and collaborate with all the different application groups at Gamma. So batteries, engine performance, thermal management, the mechanical team, and all of these groups are coming up with just all kinds of unique optimization problems and machine learning problems that I really enjoy, getting involved with.
I think along the same lines for me too. I think we have a great team. It's really a pleasure to work with such talented, skillful, and full of energy team. And this includes Ryan from the application side of things, but also our development team in Athens. Also the technical challenge. Every single day we want and we need to face technical challenges, find their constraints, their limitations, their goods. make choice, develop them, see them, happening. I will also focus a little bit on the process of integrating what we create with the rest of the tools. It's a very interesting process for me. I really like it. Enjoyed it every day. And finally, the satisfaction of the impact that we create. We see our internal users, our customers, using these tools, and what we get from them is really satisfying and fulfilling.
Yeah, and you guys are also hiring, right? There are also open
We are
positions
in the
the
process
web.
of hiring for all these different technologies that we talked about earlier.
Yeah, so if anyone listening to the podcast is interested, you can apply to this very exciting team. And with that, I think we've come to the end of the podcast. It's been a very interesting discussion. We enjoyed it. Hope you did too. So thank you so
Yes,
much
indeed.
for
Yeah,
joining.
thank you for having us.
Yeah.
Thank you so much.
Thank you to everyone for listening, and this is Abhishek and Divya signing out. Tune in for our next episode.
Thank you.
Thank you.